All right, so we've already worked with two-step equations. You should be fine with solving those now. We're going to do some two-step equation word problems. So we're going to take a word problem, convert it into a two-step equation, and solve. So let's just start off with my first example. It says, Lakorian is saving money. He started by putting $500 in a savings account. So this is what he starts with. He decided to put $100 per week in his savings account. What I want to know, and you always go to your question to figure out what you want to know, and how many weeks will Lakorian have $2,300 saved? So how long is it going to take him to save that amount of money? So whenever you get ready to write these equations, the very first thing you have to do is what we call define a variable. And you always define a variable by looking at your question and seeing what it's asking you to find. So the question asks me to figure out how many weeks it's going to take him to save $2,300. So I'm going to say W for the number of weeks. That's my unknown. Your variable is always going to be your unknown. We don't know how many weeks it's going to take him to save $2,300. But we're going to start off with what we do know. Well, what do we know? Well, we know that he started by putting $500 in. Okay. I also know that he's going to put $100 in per week. Because 100 is with the word week, and this variable represents week, I'm going to say 100W. 100 and W will go together. So he starts with $500 plus he's going to add $100 per week, which is the same as 100W. I don't know how many weeks it's going to take him to have to add $100, but I do know he's adding $100 a week. So, but what I want to know is if he starts with $500 and adds $100 a week, when will he have $2,300? So that's what this total amount should equal. So if he starts with $500, adds the $100 a week, when will he have $2,300? That's it. Starts with $500, adds $100 a week, which is $100W. When will he have $2,300? So that's how you set that equation up. And all you have to do is solve. Now, you could have used trial and error or thought this thing through using common sense. You could have used a little chart. But I'll do that in a minute. The main thing I want you to be able to create these equations. So just looking at this equation, I can tell 500 is farther away from W. It's not attached to the W, so I'm going to change the sign of it. All I have to do is solve for W, and it's going to tell me the number of weeks it's going to take him to have $2,300. 2,300 minus 500 is, I didn't need to do that. Sorry guys, I didn't need to do that. I am going to have to borrow, but I'm going to borrow from the 2. If I can get this pen to work. That will become a 1, that's 13. So how long is it going to take him to reach $2,300? All I have to do, since that's mashed together, is divide by 100. And I'm left with W, guys, which tells me the number of weeks that it's going to take him to have $2,300. I'm going to take these 1,800 divided by 100. What I can do is just cross out a 0 here, cross out a 0 here, and 18 divided by 1 is 18. Basically, it's going to take Corey 18 weeks to save $2,300. 18 weeks is 4 weeks in a month, so that's a little over 4 months, about 4.5 months. You have $2,300, Corey. If you can put 500 up and save $100 a week. Now, the other alternative, besides setting up an equation, is just to do it this way. Trial and error, what I call a trial and error chart. If you start with 500 and you save $100 a week, then when will you have $2,300. So 500 plus 100 for the first week, which means you have only 600. That's not 2,300. 500 plus 100 for the first and second week. That means you have 200 you put up. That will equal 500 plus 200, which is 700, not 2,300. Start off with 500, then save 100 for 3 weeks. Well, that's going to be 500 plus 300, which is 800. You could keep doing that until you get to 2,300 and figure out how many weeks it took by looking at this number. But that's a lot of work, okay? Some students would do that and they'll just keep guessing. And this is what you have to do. If that's what you have to do on the ACAP test, and that's fine. Suppose you put 15 in here. So 15 times 100 is 1,500. So that means it's 1,500 plus the 500 you had saved. That's $2,000. Still not 2,300. But if you bump that up to 18, you don't have to start off with 1, then go to 2, and then go to 3 weeks, 4 weeks. You don't have to go consecutively. You can bump up the weeks as you see fit, so you don't have to do a whole bunch in your chart. 100 times 18 is 1,800 plus the 500 you started with. So 1,800 plus the 500 you started with is $2,300. So you can also get the 18 that way. But that's a lot more work when you just write an equation. All right, let's take a look at the second example. Emma and her friends are going to the movies. She has a coupon for $1.50 off each ticket that she purchased. So she purchased a ticket, but it was the coupon is going to take $1.50 off that ticket. So each of her tickets is going to be reduced by $1.50. So we'll say if the ticket costs $5, take $1.50 off $5, and she'll only be responsible for her ticket will only cost $3.50. Or if the ticket is $10, if you take $1.50 off $10, you're looking at $8.50. So that's what $1 off coupon means. $1.50 off coupon represents. So here I know that the ticket is going to be reduced by $1.50. It goes on to say she and 7 other friends, which means 8 people, attend the movie, and the final cost is $52. So for 8 people, she paid $52. Now keep in mind that she had to buy 8 tickets, but for each of those 8 tickets, they took $1.50 off, each time. All right, and let's look at our question, because that's how we first define our variable. How much is the original ticket price? So I'm going to say O for original ticket price. That's what I don't know. Always go to your question to figure out what you're going to let your variable be. It could be any letter. Okay, so let's talk about how she got to that cost of $52. So her final cost was $52. So her total equal to $52. So how did she get a total of $52 to pay? Well, I do know that when she bought a ticket, for each of those, she bought a ticket for $0, okay? But they took off $1.50. Well, how many of these tickets did she buy? She didn't just buy one ticket and they took off $1.50 one time. She bought 8 tickets. Now, how do I know she bought 8 tickets? Because it says she and 7 of her friends. So she paid this amount right here 8 times. So all I'm going to do is put this in parentheses and multiply it by 8. And so she bought a ticket that took off $1.50, but she did that 8 times. So it goes in parentheses. After she did that 8 times, they told her charge was $52. So now all I'm going to do is use the distributive property And I think what I want to do is use a T instead of an O because the O looks like a 0. All right. So now I'm just going to use the distributive property to solve. So 8 times T is 8T. What's $1.58 times? $1.58 times is $12. Now the number that's farther away from the variable, but yet on the side with it is 12, so I'm going to change the sign. So I end up with 8T equals to 64. I'm going to go up here. Divide both sides by 8. Don't change the sign. We only change the sign if the number is not attached. So each ticket was $8 each. Each ticket was $8 each. That was the original ticket price. So when they took the $1.50 off for the $8, she paid $6.50. All right, it says you can write and solve an equation to solve any problem. So we want to learn how to do this. We learn how to do this. What I want you to do is take a look at number 11 and 12. Pause the video and see if you can do it on your own, okay?